Hello everyone, welcome back to another mathematics and GIS lecture video. And in this lecture video, what I want to do is I want to introduce a concept that's going to be very important for going back and forth between Cartesian coordinates and polar coordinates. And that's this idea of what is called the arctangent, or sometimes called the inverse tangent. Make that a little cleaner. Sometimes called the inverse tangent. And so I want to really quickly recap what we mean when we say the tangent, so that what the inverse tangent or the arctangent does will make sense. So let's say we have this triangle here with side length of 5 and 3. And we have this angle, we're going to call this angle theta, right? And so we know that the tangent of theta is going to be equal to, right, 3 over 5, right? That's the TOA, opposite over adjacent, right? And we know this is really useful. We found a lot of really good uses for this in terms of solving for different things like heights and different things. But what if we wanted to actually know theta? Right? What if we were given the tangent? What if we said that the tangent of theta was equal to 3 over 5? But what if we wanted to know theta, right? What is theta? Well, right now, up to this point, we have no way of answering that question, but it certainly seems like it should be possible, right? If we know the tangent, the value of the tangent, well, why can't we go back and get what theta is? It's certainly a reasonable question. And the function that does that is called the arctangent or the inverse tangent. And you will often see it written as arctan or tan to the negative 1, right? These are arctangent / inverse tangent. All right, and they do the same thing, right? This tells you theta, right? This tells you theta given the value of the tangent. Now, I will sort of skip ahead a little bit and say that there are inverse functions for sine, cosine, cotangent, and all the others. So it's not just tangent that can do this, but for the sake of converting to and from polar coordinates, arctangent is the one that you really need to be aware of. So again, just to reiterate what I'm saying here, is that we have a function called arctangent or inverse tangent that, if given a tangent, will give you back theta. Okay? So let's look at a couple examples. Let's look at this example. Right? What is theta in this example? Well, we know the tangent is 3 over 5, right? So if we know the tangent is 3 over 5, right, I'm going to pull up my handy dandy Windows calculator here, which I'm going to clear. Slide down. Clear. I'm going to delete the history. Right? And so what I can do here is I can do 3 divided by 5. Okay? So that's 0.6. Okay? So what I can do here is I can hit the Shift key and the T key. Right? Shift T. Again, that's Shift T. And you'll see here that it says tangent, but it has this -1, right? And if you remember, move this out of the way for a second here, right? Tan -1 is one of the ways that we symbolize this idea of arctangent. So the tan -1 of 0.6, which we said was the tangent, correlates to, because we're in degrees, an angle of basically 30.1 degrees, okay? So a tangent of 3/5 is equal to a theta of approximately 30.1 degrees, okay? I want to go through this again because I really want to make sure you understand, because this is a critical concept to understand. Let's say we have a different triangle, something like this. Right? This is our theta. So we have a side length of 10 here and a side length of 3 here. Right? So we know the tangent of theta is going to be equal to the opposite over the adjacent. So it's 3/10. Well, what's theta? Right? So again, it's going to be equal to the inverse tangent, right, or tan -1 of that 3/10. Okay. So the way that we do that in our Windows calculator, right, let me clear our previous example here. Right, the way that we do that is 3 divided by 10. Okay, so that's our tangent for theta. To get the arctangent, or the value of theta, we use the arctangent. That is the shift button and then the T key. Okay, shift T. You should see the -1 pop up there. And so we know that the value here is going to be 16.699. So I'm going to round that and say that it is 16.7 degrees. All right, so this is going to be equal to 16.7 degrees. Okay, this is the value of this theta in degrees. And again, there's nothing special about degrees here. This works just as well in radians. You just have to make sure that in your calculator that you switch from degree mode to radian mode. Okay? So hopefully this makes sense. Again, I know this is kind of disconnected in a way from what we've talked about, but it is nonetheless extremely important that you understand this concept of arctangent and the way that it can give you an angle if you provide it the tangent of that angle, right? So again, we gave it our tangent, it spat back our theta. So hopefully that makes sense. If you have any questions, as always, please reach out. Thank you.